again. Welcome to CyberSe Pulse webinar brought to you by Hermitage Solutions. My name is Simona, and I will be your host today as we bring Brett Hamill, solution architect from Genians, who will explain us how network access control can be used to leverage zero trust security. But more about that, you will hear from Brett. And as always, I have some housekeeping to do. So everyone is muted. And if you have any questions, please just throw them into the chat and we will answer them in real time. Yes, you heard correctly. This time we're gonna answer them in real time. However, in the end, we'll also have a dedicated time for Q&A. And lastly, we are recording this webinar, so if you have to step away for any reason, don't you worry, we'll get the recording in 2 days. So my mission here is done. Brett, whenever you're ready, please take it away.
Thank you, Simona. I appreciate it, and welcome everyone. Today we'll be discussing zero trust security, and specifically how zero trust security can be enabled and empowered by network access control. My name is Brett Hamill, and I work for Genians, and I've been in the network access control industry for 16 years, and we'll talk more about our company and network access control and how it can enable zero trust security. So here's the agenda. We will do a brief company overview so you know who Genians is. We'll do an overview of our ZTNAC product. We'll discuss zero trust security, including least privilege access, and we'll discuss how NAC plays a role in zero trust security. We will do a product tour and demo, and then we'll also look at our ZTNAC, which is the latest version of our product, and that will be discussing cloud visibility and control. First, we will start with a company overview. The company name is Genians. The main products are ZTNAC, which we'll be talking about today, Genian Device Platform Intelligence, which we will also cover today. And we have an EDR product as well, which will be getting released this year. We were established in 2005. From a time frame perspective, those of you perhaps familiar with network access control, around October 2004 was when a company called Cisco purchased a smaller company called Perfect and fed into Cisco Clean Access and eventually Cisco ICE, which is their product today for NAC. So really, as long as the network access control industry has been around, Genians has been around providing the same, so some of the bigger brand names you may recognize. It is a publicly traded company on the South Korean stock market. We have roughly 140 employees. We are very engineer-centric. We have over 1,600 customers globally. And for 16 years, we've been providing network access control solutions. Genians is #1 in the South Korean market for network access control and provides these solutions through 30+ global partners. We are also recognized by both Frost & Sullivan and Gartner. We've been growing over the last decade or more every year with our customers. We have customers in various vertical markets. So this solution is not geared towards any large enterprise markets or any particular sectors. Really, we have customers across the board, and even you know, with our global expansion, especially over the last couple of years, a lot of SME customers, so also a lot of small municipalities, small financial firms, and local governments, K through 12s, etc. So the features that you're looking at can be implemented in many different ways across very large scale enterprise or very small networks. So of course, we're going to be talking a lot about zero trust today. So there's as you can imagine, just a plethora of information out on the internet about zero trust security, zero trust network access, and a lot of terminology. So just to break it down and keep it simple, when you look at it from a model standpoint instead of a technology standpoint, what are the goals of zero trust? So there's really three primary components. There are breakdowns of this at a more granular level, but really these are the primary goals for a zero trust model and the primary principles. First, of course, you want to require secure and authenticated access. So anything that connects to the network needs to be authenticated. You need to know who or what that is before you allow any access. Even those devices which you actually deem worthy of access, you want to always give as little access as possible. So that's where least privilege access comes in. So of course, first you have to make sure they're supposed to be on the network, then they only get what they need to do their jobs or to function. And then three, you want to be able to log and inspect traffic and adapt and change if anything changes with the status of either the user or the device. So zero trust means that you constantly adapting and modifying access. So that access you assign should not be static. If something changes with the user or the endpoint, then you need to be able to adjust properly. And that may mean adjusting the level of access and the level of privileges the user or device. So keeping that in mind, how do we actually make that happen? So we look at the building blocks for cybersecurity. These align directly with the goals of zero trust access. Surveillance, of course, you can't control anything unless you first are aware of it. So surveillance is key because you want to find out who and what is on your network and what's happening on your network. You need to have that information before you can make any decisions about controlling access. Then, of course, the component includes that devices that are connecting and users and devices connecting to your network are compliant with all of your policies. So you control what they can access, you assign the appropriate privileges, and of course, least privilege access is what you assign when implementing zero trust security. And then finally, automation enables you to link together the various systems in your cybersecurity ecosystem. And that's very important because regardless of what any vendor tells you, not one product will have all of the visibility and control mechanisms to accomplish all the security you need for your network. So linking those systems together and enabling automation for those systems to share information and to perform actions is key. The products we'll be looking at today are Genians Device Platform Intelligence, which prevents the information collected via surveillance through the ZTNAC system. We'll be talking about ZTNAC and Genians ZTNAC, which is the version of our NAC product, and how those systems can enable real-time enforcement once you have your visibility. And then, of course, we have a REST API, which is available so ZTNAC can interact and share information and have bidirectional integrations with other systems on the network. Let's talk about Genians Device Platform Intelligence. Of course, we talked about with zero trust security or controlling any access, first you have to have the appropriate level of visibility. Also, the more granular the visibility, the better you can make your access control policies and the better decisions you can make. We really consider this visibility 2.0 instead of basic information like this is a phone, this is a printer, this is a PC. We give you much more information. We provide identity, contact, and risk information, and we have over 6,000 new platforms that were added in 2020. So some of the examples of this information is you get a specific platform assigned to each device, which includes information about the manufacturer, connection types. You get an actual image of the device. Then we provide you with contextual information. So you get information from a business standpoint. Is the device end of sale, end of life, and where was that device manufactured? And last, there's risk information, both from a technology standpoint and from a business standpoint. Are there any correlated vulnerabilities with that platform? And is that business actually still operating, or has it been acquired? Those could impact how well that device is maintained and what kind of software and security updates are available for that device. So this kind of visibility is key. We're going to give one example. There's many, many different examples to give, but we'll only give one example of how this information could be useful. So with Genians Device Platform Intelligence, you can leverage this information to control access for devices that meet this kind of category. So you could, for example, take the information that's collected, it's tied to a specific platform automatically, and then you can actually group these platforms together. So any device that happens to be end of sale, end of life on your network, you can group that together. Then you could do something like restrict access, deny access, or just report the status of these devices. So this contrasts heavily with the fingerprinting approach, where you get a basic device fingerprint like phone, printer, PC, and then to get any additional low-level information like end of sale, end of life, or other information such as vulnerabilities, you have to really look at third-party integrations. And then you typically would just assign everything into a particular VLAN. With Genius Device Platform Intelligence, it's a bit different. So the GDPI cloud database is linked up to your ZTNAC system. A specific platform is assigned. Everything is linked. If there's an EOS or EOL data for that platform, you can group those together and then you can do something with those devices. You could just notify, but again, this doesn't require third-party integrations and it's all integrated out of the box, so to speak. Once you have visibility, you have to think about control. Whatever system you have, you want to be able to have as much pre-canned, pre-configured options as possible to make it easy for your administrators, and you want it to be as granular as possible. So with ZTNAC, you have over 500 predefined conditions that allows you to assign access. The policy enforcement happens once an endpoint compliance status is verified, and then permissions are assigned. And you want to make those as granular as possible so you're following the zero trust model and not giving too many permissions, just the least privilege access. You're going to hear that term a lot today. Then you decide for your network, what is the appropriate enforcement mechanism? So instead of being told by a vendor, this is how you're going to use enforcement, you need to be able to choose which enforcement mechanism is best for your network. Today, we'll be talking a lot about the ARP enforcement mechanism because it's not tied to a particular network. Vendors doesn't rely on the network infrastructure, making it easy to implement and less complex than some of the other options. Although all the options you see there are available with ZTNAC, the vast majority of our customers choose ARP enforcement for simplicity. Lastly, we need to talk about automation. So we talked about visibility, surveillance, control, and then automation. This is what allows you to adapt as things change on the network. Often a next-gen firewall, for example, will be able to identify a threat, but typically will lock that threat at the perimeter. So that leaves the interior of your network vulnerable for lateral threats to move around inside of your VLANs and your network segments. So with security automation, ZTNAC can receive information from external systems like next-gen firewalls, IDS SIMs, and it can process this information through syslog or API inputs. Then it can perform a real-time ARP enforcement. So without any reliance on the network infrastructure, regardless of the make, model of those switches and wireless devices, ZTNAC can immediately use ARP enforcement to quarantine devices and layer 2 isolate devices as soon as a threat is reported by any of these external systems. At the same time, it can send out real-time notifications via email or SMS, or send out to channels like Slack channels, Teams, ServiceNow, or other systems. This is key of the last goal of Zero Trust, which is to monitor and adapt in case you need to change privileges. Before we go any further, let's talk about the components you'll be seeing a little bit more of today. The policy server is where your policies are all managed. It's the central database. As you'll be seeing, you can deploy this in a public cloud, a private cloud, a hybrid cloud. You can also deploy it on-prem by downloading the image from our website and installing it on an Intel platform of your choosing. It'll correlate all the data from network sensors deployed in your network and distribute policies. The second component is the network sensor. This can also be deployed virtually or on hardware, and is very often deployed on small form factor hardware, such as an Intel NUC or a mini PC. That way it can be distributed to branch sites easily. As mentioned, there's no integration with the network infrastructure required, and we have a fail-safe option we'll talk about later. The last component is the agent. This is an optional component, but can be used for endpoint visibility and security policies, controlling access for endpoints, collecting other information about the asset. Shows us a few things here. First of all, we have some components we talked about, of course. We've got the policy server component. The policy server component, as we mentioned, in a cloud, it's on the AWS marketplace. You can use our Genians cloud, or you can deploy it on-prem. In addition to that, you have the network sensors, which are distributed throughout the network. These are very easily deployed and just connected to a port. If you want to monitor multiple VLANs, you just make that a trunk port. And that's all the integration you need. You don't need to configure your switches, your access points, your controllers. You don't have to configure a mirror port or span or radius. You don't have to do any of that. So you can deploy sensors in the middle of the day during production. Sensors don't require high availability typically because they can fail open. So there's no single point of failure. They are truly vendor agnostic, so we don't care about what infrastructure you have, and you can deploy these very rapidly. This model right here, this diagram shows the zero trust mode. So in other words, you can turn on your sensors once they collect information. You can designate all devices you know and recognize as trusted, and then any new device would be on by default. That's really the default operating mode for zero trust security, is unless you explicitly trust something, don't let it connect to the network. You can also use ARP enforcement for segmentation, not just to block devices. So one of the things we talked about was for zero trust security is that even devices that you want to allow on the network should only have the least privilege access. So what you can do is you can logically define in ZTNAC specific access for users and devices or user device combinations. These are defined in software, not on your network infrastructure. So these permissions actually follow users around on the network. And if anyone else has any audio issues, please let us know. I see one user that, one attendee that posted a note, but please let us know. So also, we have demos available outside of this. So if you're interested in a demo, please let us know and we can schedule one-on-one time with you. So these segmentation policies are very easy to configure. So step one, you can use any type of qualifier like a node tag. Then you can assign that tag to nodes and you can group those nodes together and then assign specific permissions. And then no matter where that device goes, it will always have those permissions. Why is segmentation so important? The reason is if you look at legacy privilege access, you had static segregation at the network level. So basically, in a legacy network and your legacy privilege access, everybody in sales would be on one VLAN and they would all have the same access. And people in other departments, same thing. The problem with that model is that if there's a compromised user device that is on that VLAN, the attack surface includes the entire VLAN and all the devices and servers and applications and other users. So this is why legacy privilege access is a bad idea. With least privilege access, you're going to give only the minimum amount of access required. What this means is if there's some type of a compromise, the attack surface is reduced. So the amount of components, systems, users on your network that can be compromised is much smaller. This is the key of why least privilege access is so important. Of course, remote access comes into play as well. So you want to be able to do the same thing you do for remote users as you do for users that are on premise. So this is an example of where, of course, an unauthorized user with invalid credentials or a non-compliant user who is an authorized user but doesn't have the appropriate security posture are simply not allowed on the network. However, following the least privilege access model, anyone who is compliant still should only get specific access. So user A and user B, maybe they don't require the same amount of access. They shouldn't both have full access into the entire internal corporate network. So you still want to be able to assign least privilege access even for your remote users that are connecting to your network. So before we get into this next section, we're actually going to do a brief demo and a tour of one of our systems. So I'm going to switch over. We talked a little bit earlier about how you can have your policy server deployed anywhere you want. So you could have it in the Genians cloud, which is where this policy server resides. So this policy server resides in the Genians cloud, and any of our customers can utilize this cloud, or they can use their own cloud, which we'll show you more about in a minute. So this is a dashboard overview of all of the nodes that are on the system. Of course, you can see there's various information collected about these nodes and a certain high level of detail. And you can also adjust your view and use any kind of dashboard you'd like to use to give you the different view you're choosing depending on what is more important for your environment. Perhaps wireless is more important for your environment. Perhaps wired is more important for your environment. Maybe endpoint security is the most important thing. So it really depends on what your goals are, but you can adjust these views accordingly. So again, this is a cloud policy server here. And then here we have the sensors. So we talked about the sensors that would reside on a particular network. So for example, here is a sensor at a corporate office in San Jose monitoring one particular VLAN. So you're going to get information about all of the nodes connected. This information includes connection information, IP address, MAC address. You're going to get information about the enforcement policy. One key item here is that the default enforcement policy is what everything matches on initially, and everything has full access to the network initially, which means that you can turn this on the middle of the day with no impact, just in monitor mode, and still see everything that's on your network without worrying about disruption. You also get information about the access port, the switch, or the wireless network, and other detailed information relative to all the nodes. The device platform intelligence information is a little bit different than the typical device fingerprinting, and this is key for Zero Trust. So what we talked about earlier was how device platform intelligence provides you more detailed, low-level information. So we'll look at an example of one of those. If I click on this right here, it will provide information from our Genians Device Platform Intelligence Cloud database. There you'll see an image of the device. You'll see information about the device platform, including a link to the manufacturer's page. You'll get information about end of sale or end of life, if there's applicable information there, connection information, fingerprinting information, manufacturer information so you know where it was manufactured, and any correlated vulnerabilities. Also, to provide additional visibility, you have optional integration through SNMP, where you can just plug in your SNMP read community string and you'll get all this information. This information may help you make your Zero Trust access policy decisions. The same thing goes for wireless. If you have a wireless network interface and your sensor that you deploy, you get information on all of the wireless networks in your surrounding area. This can be important in highly populated areas or shared office spaces, and you can group these wireless networks together as corporate or non-corporate SSIDs, identify rogue SSIDs, etc. So there's many other features to cover here as well, but we only have limited time and we want to show you much more information, including another system. But please let us know if you want to have a personal demo. We'd be happy to set one up. So back to where we left off. Everything I've showed you so far is the Genian Next Gen Network Access Control System provides all the functionality we just talked about. But in order to understand where network access control has to go, we need the history of network access control. So early generation network access control systems were very basic. They provided access control typically through something like 802.1x or VLAN switching, and they logged some basic information. That was it. But as security requirements increased and demand increased, many other features had to be added in order for the proper visibility and control to be present. So one of the key things that was added was different types of network control. So ARP enforcement, for example, sensors. That way you weren't tied to the network infrastructure and it was less complex to deploy. But on top of that, virtualized options were added. BYOD phenomenon, of course, came along, so onboarding and guest management had to be taken care of. Agents were added for endpoint visibility and security. Security automation that we just talked about was added. Cloud management options were added. And of course, the ability to identify IoT, OT devices, so more granular fingerprinting. However, even this is not enough today because, as you know, the network perimeter is essentially dissolving. So any user can be anywhere connecting to any resource. Sometimes it's just a user and a cloud resource. So all of the focus and attention you've put on access to your internal corporate network may no longer apply. So our Genian ZTNAC product is designed to address those challenges. So we saw the focus need to be in 3 areas. Of course, Genians ZTNAC is all based on zero trust principles. Always verify, never trust by default, and always give least privilege access. However, we wanted to focus on 3 areas. First, cloud. We wanted to provide cloud visibility so you could see what was going on inside of your cloud environment. Also, we wanted to have cloud enforcement options so you could actually enforce policies in the cloud environment. Second, endpoint required enhanced capabilities. So things like EDR and integrated agents with both NAC and VPN agents were added. And then lastly, network traffic analysis to be able to determine what's happening on the network. And that way you can make the decisions and actually have network detection and response to be able to respond to information that's coming in from the network as the environment changes. And lastly, network overlays are very important these days, which allows you to take your capabilities of the ZTNAC system and extend networks across your enterprise using various options. So with the ZTNAC, you can deploy your policy server anywhere. There will be a compliance check that takes place using platform intelligence and of course our policy engine. You'll have a zero trust matrix calculation based on the user, the node, the status, what resource you want to provide that user or that node. Then you have to choose your enforcement method. Of course, previously we talked about ARP, SNMP radius, and we of course talked about agent, but now the agent is applicable for both home and cloud applications. And then for the cloud, we've added a cloud connector and gateway to allow control in cloud environments. Network traffic analysis, we're going to take information from various sources on the network, forward that to your policy server, wherever that policy server resides. We're going to perform a network policy check to make sure that there are no violations that occur, match that up with the policy engine, and then of course, choose the enforcement method and enforce it in the user environment. The network features, including virtualization, we added to our sensors the ability to act as a VPN server and also act as a VPN endpoint for IPsec tunnels. We added VXLAN capabilities, so it can act as a virtual tunneling endpoint, and also GRE tunnel capabilities were added. So what this means with these added capabilities is now you can provide client VPN access anywhere, especially to control access to your cloud and your cloud resources. You can also establish site-to-site VPNs over your sensors and then perform network overlays so you can use VXLAN, for example, to extend networks across your enterprise and keep your policies simple and even enable features like IP mobility. And last but not least, one thing we're going to take a very close look at here in the next portion of the demo is the cloud visibility and enforcement. So you can use various components that we talked about for visibility, whether it be a sensor, a virtualized sensor in the cloud. You can use our cloud connector. And then of course we have our agent, which is both a NAC and VPN agent for a zero trust agent. Your policy server deployment can be either public cloud or private cloud. And then of course, in the cloud, we're really looking at your agent or your connector and your gateway to actually perform control functions to control access to the cloud or in the cloud. So here's a couple of examples. You can mix and match these combinations, but really the policy server deployment does not matter. It can be on-prem in the Genians cloud or in your cloud. So that doesn't matter where it resides. The cloud service provider also doesn't matter. So I've got the top 3 listed here, but it's really not relevant. You can enable and gain visibility no matter what the cloud environment. And then here's some of the visibility examples. We can use our cloud connector. We can use a virtual sensor deployed in a cloud or your agent to gain visibility. So here's an example of gaining visibility through the connector. basically, regardless of where your policy server resides, you can use the cloud connector and you can obtain information about cloud resources. So any nodes or any IP-enabled device in your cloud, you can collect that information and send it back to your policy server. Another option is the virtual sensor visibility example. So in this option, again, your policy server can be anywhere. And then you can deploy the virtual sensor anywhere. This is an Azure example. And once the sensor is deployed, information about other IP-enabled nodes in that cloud environment will be again forwarded back to the policy server. And then last, agent visibility. So let's say you have your policy server in AWS, doesn't really matter. You could have Google Compute instances with the agents installed and still get that information reported back to your policy server. So a cloud, multi-cloud, hybrid cloud, it doesn't really matter what your environment is. You can use these tools to gain visibility. The end result is a collection of various nodes that you achieved information about through different options that we just talked about. So whether you're using an agent or a sensor or a collector, you can collect information from all these different environments and have it all in a single view instead of having to manage it in several different views. So now, how do you actually control access in the cloud? We have visibility, so now we need to control. Of course, we know the policy server can reside anywhere. Your service provider in the cloud is not really relevant, and we can use some different control mechanisms. We'll talk more about the cloud connector and the agent option. So here you'll see we can use our cloud connector to actually control. So in this instance, you could have your policy server sitting anywhere. The cloud connector, in addition to collecting information about the environment, can also enforce actions in the environment, such as shutting down a virtual instance in the cloud. If that's too severe, you could also use your cloud connector to modify access using various options. In this example, the security group for an EC2 is removed and replaced with a new modified security group that may quarantine or restrict access. So the instance stays running, but you can change the level of access that that cloud instance has. And then lastly, you can use the agent access as well. So regardless of where your policy server is or where the other cloud instance is, if there's an agent installed on that endpoint, you can leverage things like the built-in firewall to restrict access. So we're going to take a quick look at another system. So previously, you'll recognize that we were actually in the Genians cloud. This is a policy server that is in AWS. So as you can see, it doesn't matter where the policy server actually resides. So I'm going to actually log in to this policy server in the AWS network. And this is available, by the way, on the AWS marketplace. You can deploy it straight from the marketplace. Of course, the dashboard looks similar. This is the ZTNAC product, so it's branded a little bit different. But if you look at our node list here, what we're going to see in the node list are various nodes that we've collected information on. So here you've got information on nodes that are deployed in AWS, nodes that are deployed in Azure. There's a work from home user. And then here's an Oracle Cloud Infrastructure device as well. So it really doesn't matter where your devices, your cloud devices reside. You can gather information and then you can perform actions. So one of the actions we can perform, as I mentioned before, is to be able to do something to cloud instance. Of course, regular next-gen NAC access control for on-prem works great, but we need to extend that to the cloud. So here what we're going to do is we're going to look at these instances we have here. And one of the instances is this test Windows server right here. So here's the IP address. 17.119. So what we can do is we can actually go in here and we can assign a tag which will actually shut this system down. So this is something I'm doing manually for demo purposes, but this threat tag could be assigned dynamically in real time by getting a threat from an external system like an next-gen firewall or an IDS. So once I assign this threat tag, now we see that this particular device is matched on the threat, and we're actually using the wrong policy, but I'm going to demo both of these so it doesn't matter. So this policy that we've matched on is we're using the agent to actually block. So instead of a shutdown, because this has an agent installed, we're going to actually use the agent to block that. So what I can do is I can actually log in. Okay, so this is actually the EC2 instance. This is the cloud instance, the Windows server, and we've got a pop-up here that it's blocked. So if I refresh this, you can't reach the page. So basically, we leverage the agent to actually block this Windows server's external access. So it's an EC2 Windows server, and we blocked external access using the agent firewall. So if we come here, and I want to actually change that status, so I go to my node list. Again, for demo purposes, we can do this manually, but you can dynamically assign node tags based on a syslog event or an API call from an external system. So what we're going to do is we're now going to remove this tag, so there's no longer a threat. And we'll see now that this no longer matches on that policy. The tag was removed. And then if I go back to the actual instance, should see here. Make sure that got removed from policy. Yeah. Let's see if there's an agent is communicating. So essentially the firewall rule should be getting revoked and access should be coming back. So normally this happens within about 30 seconds, but if you ever want to have a problem with a demo, just have a webinar. So, so anyway, this is supposed to be getting access now, which is not, so we'll come check it back on that in a second. And your other options here for policy enforcement are to modify the ingress ACLs or security groups, or to actually shut down nodes. So what we can actually do is we'll try to do that second demo, and then we're going to break for questions. So let me try to demo this other item. Okay, apply that. And then let's take a look and see if this has changed. We're going to switch this to a agentless environment to do our next test. All right, we'll see if we can trigger our agent list. So go back here. All right, that's all set. So what we'll try to do now is trigger a shutdown. Here's the two instances running right now. So now we're going to go ahead and add a threat tag again to this AWS node. So now you see the threat tag assigned, and it matched on a different policy, which is shut down the EC2s. So if I go back and look at the policy, I can see now that one node is now matched on this one instead of the agent policy. So we'll go back and look. So this was the EC2 that was running, and there you see it's stopping. So what this means is you can enable security automation. If something in your network is monitoring or in your cloud environment is monitoring for threats, we can ingest that, and then we can actually stop that EC2 instance in real time. And there you'll see it stop. If something changes and it's no longer a threat, we can actually revert it and we can actually start the instance. So now we're going to go in here and remove. So there's the threat tag. We're actually going to remove that. So everything is back to normal. There's no longer a threat. And there you see the tag is gone. It's matched on the default policy, and it says the node tag was removed. So now we're going to go look at the instance again. Let's refresh it, and it's starting and it's back up and running. So long story short is, regardless of where your end users reside or where these devices reside, whether you're talking about on-prem, work from home, cloud environments, or OT out in a factory, Genians ZTNAC can actually collect information, perform assessments, and then actually use all sorts of different enforcement options to make sure we can quarantine devices regardless of where they connect. So if you're a user at home, you don't comply with policy, we can actually quarantine you or restrict you. If you're on-prem, of course, we can do the same, but that now extends out into the cloud. So we're going to take a break here and see if we have any questions.